Here we are with Unit 7, Lesson 3, powers of 10. So we're going to be talking about what it means to have a power of a power, and specifically of 10. We're really just using 10 as our base all the way through. So we're going to talk about powers of 10. This first one, we have a big cube. And we're not just saying a big cube. We mean like a big cube, where that cube, we know that a cube starts out as has a square for all 6 of its faces. That cube has 3-dimensional value to it. And within this cube, what we're saying is that it measures 10,000 kilometers on each side. That's a big cube. So we're talking 10K right here, 10K right here, 10K all over the place, 10,000 right here. But when we find the volume of that cube, what we're after with the cube, sorry, that just moved all over the place. The volume of a cube is equal to the length times the width times the height. And multiplying 10,000 times 10,000 times 10,000 doesn't seem like a big deal, but it's going to give us a really, really big number. So there's got to be a way to make this a little simpler. If we take this value, what we're talking about, we take the length, the width, and the height, knowing that they're all the same, we can take the value of 10,000 and first turn it into a power of 10. That power of 10 is going to be 10 to the 4th power. And I know that because if I take 1 and multiply it by 10, it's going to take 4 place values to figure that out. So 1 times 10 to the 4th power would be actually written as what we call that scientific notation. And then 1 times 10 to the 4th power would simply just give me 10 to the 4th power. So now when we think about this and we talk about the volume, we would think about the volume is equal to 10 to the 4th power. But that 10 to the 4th power would be the length times the width times the height. So we got to think maybe there's got to be a shorter way than to write it out 3 different times. We could simply say the volume is equal to 10 to the 4th power times itself 3 times, which would make it right here. We can see that's 10 to the 4th times 10 to the 4th times 10 to the 4th. There's 4, 8, and 12 tens. This one would equal 10 to the 12th power. And then what we notice, the shortcut with that is 4 times 3 is also 12, so 10 to the 12th power kilometers cubed. That's a really, really big cube. You think about that. That's 12 place values after the 1. That's a big number. That's actually more like a billion. Let's see here. 9, 12. That'd be 1 trillion cubic kilometers. It's a pretty big place. Okay. Let's think about this next section right here. It says taking powers of 10. As we just talked about, a power of a power is taking the power out here and raising another power inside of the grouping to a larger power. So when we say a power of a power means that we're going to take an exponent times an exponent. Your job here is to complete the table to explore patterns in the exponents when raising a power of 10 to a power. You may skip a single box in this table, but if you do, you have to be prepared to explain why you skipped it. We see this first one as 10 to the 3rd power squared. This squared is a good way to represent or to understand that this is 2 groupings of this group, or I'm going to take that group twice. So we see 10 to the 3rd here, and a second group of it, 10 to the 3rd here. And then when we just look at that multiplication of the expanded version, that's a set of 3 and a set of 3 being multiplied together. So in reality, that's just 10 times 10 times 10 times 10 times 10 times 10, or 10 to the 6th power. We see in the next one, we see 10 to the 2nd power raised to the 5th power. So we have 5 groupings of 10 to the 2nd power, 5 groupings of 10 to the 2nd power, 10 to the 2nd power, 10. Right? You get the point. We go 10 times 10 times 10 all the way through the end. And I see that 10 times 10 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And not only is that counting and just adding them all up, 10 to the 10th, we have a shortcut we can do is 10 to the 2nd times the 5th. I look at this next one in my expression. I see 10 to the 3rd, 10 to the 3rd, 10 to, I see 10 to the 3rd inside of my groupings. And then I see the groupings 4 different times. And then when I count up all these 10s, I get 10 to the 12th power. When I look at 10 to the fourth power squared, we're going to see 10 to the fourth power grouped up twice for a total of 10 to the 4 plus 4 is 8 power. In this case, 10 to the 8th power raised to the 11th power. That means I'm going to see 11 grouping. Oh man, 11 groupings. That's just kind of ridiculous. I can handle 5 of them with just a couple of numbers inside, but to do 11 of them with 8 in the middle, that is just completely and totally. Um, oh my goodness, I just lost the word. Aaron, you're supposed to be here to help me with this one. Okay, it'll come back to me here in a minute. 10 to the, let's see if we can figure this out. For the rest of these, we got 6 from 3 and 2. So we must have multiplied. 10 was 2 times 5. 3 times 4 was 12. 4 times 2 is 8. So 8 times 11. I would be writing out 10 times itself 88 times. 88 times. That's just going to take way too long. And guess what, Aaron? I remember the word. That is just completely inefficient. So those of you who are laughing at me, whatever. If you chose to skip one spot on the table, why'd you skip it? Well, I chose to skip the last expanded box. Because expanding 8 or 10 to the 8th raised to the 11th is just inefficient. I can come up with the single power 10 way quicker just by understanding the process of what's going on here, recognizing this is 11 groups of 8, and recognizing that I can multiply those two exponents together. In fact, what we're seeing is the pattern that we followed in the table. We rewrite this expression 10 to the mth power raised to the nth power would recognize this as 10 to the m times n, and that would just be our shortcut to powers of powers. In this case, it's all powers of 10 because the bases are all 10. When we put that to work right here, if you took the amount of oil consumed in 2 months in 2013 worldwide, you could make a cube of oil that measures 10 to the third power meters on each side. So if we're talking about a cube, again, think about that amazing drawing I had there on the front page, like this. That cube is 10 to the third by 10 to the third by 10 to the third everywhere around. And so by following that formula for the volume of the cube, we talk about length times width times height. How many cubic meters of oil is this? Do you think this would be enough to fill a pond, a lake, or an ocean? Well, keep in mind that the volume here is going to be equal to 10 to the third power times itself 3 times, because the length, the height, the width. So really we should be thinking about this as the volume of 10 to the third power raised to the third power, which would give us a total volume that is equal to 10 to the ninth power. So if that's 10 to the ninth power, keep in mind this is cubic meters of water, of oil to the third power. 10 to the ninth power looks like this. That would be 1 billion cubic meters. To give you an idea of cubic meters, that's over 3 feet by 3 feet by 3 feet. And we're talking about over 1 billion of those. That is a very, very large space. Would it fill up a pond, a lake, or an ocean? I want you to give that with some thought. I want you to decide which one of these of the three, a pond, a lake, or an ocean, is most reasonable. Don't do any guessing. I want you to really come up with a good reason why. And what you may want to do is go on in there to Google and say, how many gallons is 1 billion cubic meters? Okay, ask that question, see what it is. Leave me a private comment in Google Classroom and let me know what you've got. If you post it as a public, you won't get any credit for anything for figuring that out. So how do the rules work? Well, Andre and Elena, they want to write out 10 to the second power times 10 to the second power times 10 to the second power with a single exponent. Andre says when you multiply powers with the same base, it just means you add the exponents. So 10 to the second times 10 to the second times 10 to the second would be like saying 10 to the second plus the second plus the second, which would equal 6. Elena says 10 to the second power is multiplied by itself 3 times. So 10 to the second power times 10 to the second power times 10 to the second power could also be written as 10 to the second power raised to the third power. And then we're going to go ahead and add those two exponents together, making it 10 to the fifth power. Do you agree with either of them? Remember, you could agree with Andre, you could agree with Elena, you could agree with both, or you can agree with neither. I want you to take a minute and tell me what you think. Okay, thanks for filling that out. Now let's look at something. If we break this all out, 10 to the second power is going to look like this. 10 times 10 times 10 times 10 times 10 times 10. Do you need to change whose side you're on? Are you still siding with Andre? Are you still siding with Elena? Neither one or both? Well, Elena just says that it's 10 to the fifth power. So I know that Elena's not right because she's short one value. And what I would say to Elena, I'd say, Andre, you're correct. But Elena, what we need to remember is that when we take a power of a power, we need to multiply the two powers together because it represents a number of groupings. So 10 to the second power would be grouped up 3 different times. And so we'd have to say 10 to the sixth power. All right, one more little challenge here. Are you ready for more? 2 to the 12th power is equal to 4,096. How many other whole numbers can you raise to a power and get 4,096? Explain or show your reasoning. Good luck with that one. It's completely on your own. This lesson is done. In the lesson summary, the thing we have to recognize is this. We developed a rule for taking a power of 10 to another power of 10. Taking a power of 10 and raising it to another power of 10 is just simple as multiplying the exponents. What we see happening here is when we take this one, say for instance, 10 to the fourth power to the power of 3, we take the base, the 10 to the fourth becomes the base of 3. And so what that tells me is that I now have a base being raised to that power, or 3 groups of the base, 3 groups of 10 to the fourth power. And so 10 to the fourth power times 10 to the fourth power times 10 to the fourth power, we know when it's written out like this, and we talk about a product of powers, I can simply add up the exponents, or 4 plus 4 plus 4 is 12. But what we can really think about is this, as a shortcut with that, is we could say 3 groups of 4 is equal to 12. We're just simply 10 to the fourth times the third is equal to 10 to the 12th power. This works for any powers of 10. For example, 10 to the 6th power raised to the 11th power. It's 10 to the 66th power. This rule, this is another rule that really makes it simpler to work with the exponents and to really help us with our efficiency piece of this. So don't forget that writing out something that's really big like this one, or even like this lesson summary, you might enjoy writing out a number with 66 place values after the 1, but I certainly don't. So remember about efficiency, remember about those pieces, use these skills and strategies to help you with the homework. Let me know if you have any questions. Hang in there and have a great day. Aaron, quit laughing at me.